Hello everyone, welcome to the channel. In this video, we will see impulse and momentum. Okay, so first we'll understand what is momentum and what is impulse. So, momentum, momentum is a vector quantity. That means it will have a magnitude and direction. Magnitude and direction. So, momentum is used to measure the motion of an object. Okay, momentum is used to measure the motion of an object. Motion of an object. So, of an object. That means the momentum will depend on mass of the object and its velocity and its velocity. So in general, momentum will be equal to mass into velocity. Okay, so the unit for the momentum will be kg. V is mass per second, sorry, meter per second. The momentum will be kg meter per second. So momentum is a vector quantity. It has a magnitude and direction, and it is used to measure the motion of an object. So whenever we talk about the motion, that means the object will have the mass and the velocity. So m into v. This is momentum. And the second one is impulse. So when we talk about impulse, so impulse is nothing but a large amount of force. Okay, large amount of force acting on a body, acting on a body, acting on a body for a small period of time, for a small period of time. Okay, so this impulse can change the direction or else momentum. Okay, I'll say momentum. So how? So if we just will take an example of a cricket, a batsman is hitting a ball, right? So in that particular time, the bowler will be bowling the ball at a speed of like 120 something, and the batsman will swing the bat. So what happened that when the ball or else when the bat hit at the ball, so here we'll have a collision between the bat and the ball. Now what happens is that the ball is changed direction. This is the meaning of impulse. So for a large amount of force will be exerted from the bat, and this force will cause, or this collision will cause the change in direction of the ball. So this is impulse. Okay, hope you understood. So momentum is nothing but measurement of the motion of an object, and the formula for that is mass into velocity. Impulse is nothing but a very large amount of force will be acting for a small period of time. Okay, so now to solve the problem under impulse and momentum, we have to remember two formulas. One is the conservation law of conservation of momentum, law of conservation of momentum. That is initial momentum equal to final momentum. Initial momentum equal to final momentum. Okay, just imagine we have a, a ball of mass 1 and we have a second ball of mass 2. So here, so this is, we have two bodies, right? So initial momentum, so this object m1 will have m1 v1, or is mass into velocity, and this will also have the, at initially we have m2 v2, right? So once it is collide, we'll have the change in direction. So again we'll have the mass into velocity, right? So that is the initial momentum equal to the final momentum. So the formula for this will be m1 u1. So here we are going to take m1 v1 as initial velocity plus m2 u2. So this u1, u2 are nothing but the initial velocities of both the bodies, equal to m1 v1 plus m2 v2. So now here v1 v2 are nothing but the final velocity. Okay, there is one more formula, that is a coefficient of restitution. So the symbol for is E. So this is equal to, we can take velocity approaches, velocity of separation, that is after collision, velocity of separation divided by velocity of approach. So this will be equal to, velocity of separation is nothing but, so after collision the velocity will be changed, right? So first separation means we'll have the velocity v2, right? For separation we have v2 minus v1 divided by approach is initial velocity, that is u1 minus u2. So this is the formula for coefficient of restitution. So we'll have to remember these two formulas. One is law of conservation of momentum, another one is coefficient of restitution. So restitution is nothing but, whenever we have a collision, so in that small period of time the body will regain or deform its shape. So that part is called as a coefficient of restitution. Okay, so now based upon this basics, we'll try to solve one problem. Okay, so the problem one states that a bullet of mass 0.01 kg. So here they have given the bullet of mass of 0.01 kg and is fired from a gun. It's fired from a gun of mass 2 kg. So we have two bodies now. Here we'll have two bodies, that is one is a gun and another one is a bullet. If the bullet leaves the gun with a velocity of 100 meter per second, find the recoil velocity of the gun. Okay, if you see, so given data at initial mass 1, that is a mass of a bullet. So I'll take it mb, mass of the bullet equal to 0.01 kg, and mass of g, that is a gun, is 2 kg. Okay, and if the bullet leaves the gun, the velocity, that means here the velocity of the bullet b equal to 100 meter per second. We have to find the velocity of gun. Okay, the recoil velocity of the gun. What a question mark. See, so we know that by law of conservation of momentum, initial momentum equal to final momentum, right? Initial momentum equal to final momentum. So we say that initial momentum is nothing but m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So here the m1 m2 are nothing but the mass of the bullet and the mass of the gun. So I'll take it m1 as mass of bullet mb, so m2 as mass of the gun g. So here I can have u and this is g. Okay, in similar manner I can rewrite this as well. So this will be, so initially 1 1 1 1, this will be mass of the bullet 1, sorry, it is the initial final momentum, so b2 mg2 and vg2. So initial momentum here it will become 0, because when you are firing the gun, what will happen is that at the initial it is at the stationary right now. So when we just trigger the when we just click the trigger of the gun, then only it will gonna fire, right? So initially this will become 0, the initial momentum will become 0. Here we'll have only final momentum. If you see the final momentum, the mass of the b2, that is the mass of the bullet, is nothing but mass of the bullet is 0.01 and the velocity of the bullet, so that means its velocity is 100 meter per second, plus mass of the gun, mass of the gun is 2 kg, and we have to find the velocity of the gun at the second this thing. So if you see here, if you put it in the calculator, we'll get the velocity of the recoil, that is the velocity recoil of the gun will be equal to minus 0.5 meter per second. That means the gun is moving in the opposite direction of the bullet, because when the bullet fired from the gun will have some small impact, so that makes the gun to go behind. Okay, that is called the recoil velocity. So after firing, the gun velocity will be equal to 0.5 meter per second. I hope you understood this basics of impulse and momentum with a small problem. In the next video, we will see another problem on impulse and momentum. Thank you for watching.